So first, what is right angle triangle? So let's start with so this is what we call a right angle triangle. This kind of angle with kind of like you have an L shape, and just you have a line joining the two endpoints. So this right angle triangle, and one speciality about this right angle triangle, it has this angle of 90 degree. So this is the right angle triangle angle. This right angle is an angle of 90 degree always. So, and if you look at the angle, the triangle has three sides, A, B, and C. So, so if you look at this right angle triangle, this opposite angle C, that is what we call the hypotenuse. So we call this hypotenuse. So suppose even if the right angle triangle, suppose it is like this, and we have here 90 degree, then this line here, this opposite side, this is what we call the hypotenuse. Well, the two other sides are called adjacent and opposite. So this adjacent and opposite depends on the angle that you are looking at. So suppose we are looking at this angle, maybe call it theta. Then we look at what is the opposite of this angle. The opposite is this. So this is what we call the opposite. We already have our hypotenuse here. Then this is what we call the adjacent this side. So similarly, like in this case, if you think maybe your angle, this is your angle, then this is the adjacent, this is the opposite, sorry, because the angle is here, this is the opposite, and this is the adjacent. So what is Pythagoras theorem? Pythagoras theorem states that this side, the length of this side C square is equal to the length of this square plus this square. So this is what the Pythagoras theorem stated. So it's stated like the square of the longest side, that is the hypotenuse, is equal to the square of the opposite plus the square of adjacent. So for instance, an example, like if you have a right angle triangle like this, and maybe this side is 3, this side is 4, and you're asked to find x. Then we just use this Pythagoras theorem. Here our C is x, our A equal to 3, our B is equal to 4. Then to find C, we use the formula C square is equal to A square plus B square, and this is just x square is equal to 3 square plus 4 square. And we have x square is equal to 3 square is 9, 4 square is 16, so this is 9 plus 16, and x square is equal to 9 plus 16 is 25. Then this implies that x is equal to square root of 25, and the reason why I do not put plus or minus because it's side, it's the length of side, so it can never be negative. So then square root of 25, this is just 5. So if to say this is in centimeter, so I can see this side x is 5 centimeter. So similarly, if you are going to find A or B that is opposite to hypotenuse, you can use the same formula. And now we will talk about trigonometric ratio. Suppose you have a right angle triangle. Let's see, here is the angle. Here's your angle, maybe theta. Then the trigonometric ratio are just this trigonometric ratios such as sine, such as cos, sine theta, tan, etc. and so on. So remember that if you have this right angle triangle, this is our angle, so this side is the opposite, this side is the adjacent, and this side is our hypotenuse. So using the trigonometric function, state that sine theta is just equal to opposite over hypotenuse. The length of the opposite side, the length of the opposite side divided by length of the hypotenuse. So we can just write what is the length of the opposite side. You can see is A over the length of the hypotenuse, which is C. So this is sine theta. So we have sine theta is equal to A over C. And if you want to find theta, you can just say your theta is just sine inverse of A over C. So you just take the sine to the other side, it's just sine inverse. So the cos theta is just this adjacent over hypotenuse. So this is this adjacent B over C. And tan theta is equal to opposite, this side, opposite over adjacent, that is A over B. So if you have cos theta is equal to B over C, then this implies theta is equal to cos inverse of B over C. And if you have tan theta equal to A over B, this implies that theta equal to tan inverse of A over B. So if you have this, so the next is and we usually use this tan whenever we want to find the angle. So we find our A, B, then use tan inverse. And from here we have a mnemonic in order to understand this, which we call a SOHCAHTOA. So SOHCAHTOA. So this is sine. If you have sine, this is opposite over hypotenuse. This is adjacent over hypotenuse, and this is tan. This is cos, and this is opposite. So yeah, opposite over adjacent. So this is just a mnemonic in order to easily memorize the trigonometric ratios. An example now, suppose we have a right angle triangle. Let's see, it has an angle here, theta, and this side, the hypotenuse, let's say is 5. And we know the opposites, let's say maybe is 3, and we want to find this angle. So whenever we want to find this angle, then we'll just, the first thing is to find what is this side. Let's find this side. Then let's just remember from our Pythagoras theorem, this is C, this is B, maybe this is A. So, and if you remember, C square is equal to A square plus B square. Then from here, we'll have our C is 5 square. So our C here is 5 square is equal to our A is what we don't know. Let's just call it x square. Well, let's leave it still as A square since we don't know that. A square plus B square, that is 3 square. Here we'll have 25 is equal to A square plus 9. A square plus 9. And from here, we want to find A square, we can add minus 9 to both sides. Since here we have plus 9, so we'll have 25 minus 9 is equal to A square plus 9 minus 9. Sorry, my A looks like the 9. Let me even write it in the red so that to separate it from the other one. So then here we'll just have 25 minus 9, this is 16, is equal to A square. And since A is length, so if we take the square here, it will just be root 16 without the plus or minus. Since it's length, it can be negative. So we have 4 square root of 16 is 4, 4 is equal to A. So we have our A is equal to 4. So we have A here, this side is equal to 4. Then since we want to find this angle, then we can just remember tan theta is equal to A over B. That is, sorry, in this case, yeah, B over A, not A over B, because it's opposite over adjacent. So this is B over A using SOHCAHTOA. So then from here we have tan theta is equal to, our B is 3, our A is 4. Then from here we have theta is equal to tan inverse of 3 over 4. Then if you can put the tan inverse of 3 over 4, this will give us, in degree, it will give us 36 points around 87 degrees. So this angle is 36.87 degrees.